Good evening, ladies and gentlemen. We are at the fifth day of AICTE ATAL Faculty Development Program on Climate Change, Impact on Environment, conducted by the Department of Chemical Engineering, Amarjyoti College of Engineering. We are very happy to have you all join us back for the fifth day of the training. We already have a distinguished speaker with us. Our first session will be on the topic decarbonization strategies for a climate resilient future. I kindly welcome Professor Dr. David K. Daniel to introduce and welcome our speaker for the day. Please, sir. Sir, you're not audible, sir.
Am I audible now?
No, sir, you're still not audible.
Yeah. Very warm welcome to our.
Sir, we can't still hear you.
Very warm welcome. I think somebody's mic is clear. Yeah, now it is okay. Can you hear me now? Hello.
Yes, sir. Yes, sir.
Yeah. So
You are audible.
I think it is a pleasure for me to introduce our speaker today, Dr. Ullas Krishnan, who has graduated in chemical engineering from TKM College of Engineering and in 2008 and obtained his master's degree in 2011 from Government Engineering College, Trichy in process control. He had started his career as a lecturer at the SCT College. Subsequently, he joined as the assistant professor at Mohandas College of Engineering from 2011 to 16. During that time, he got the best teacher, best faculty award in the year 2015-16. And followed by that, he has joined the National Institute of Technology, Tiruchirappalli, Tamil Nadu, as a full-time PhD research scholar in the Department of Chemical Engineering. And he completed his PhD in 2023 in the area of carbon dioxide to valuable product and prospective decarbonization. He has received several recognitions and awards, like the Best Oral Presentation Award at the ICON-Bees 2021 International Conference. He has also received the Best Paper Award in the Oral Presentation for the paper titled Alumina-Based Multi-Metal Catalyst for E-Waste Management for Reclamation of Valuable Products in the International Conference of the IICHE ChemCon 2023. He has also received the KTK Foundation Delhi Bharat Gaurav Puraskar for contributing in the field of chemical engineering in the year 2023. He has published several peer-reviewed articles in journals of international repute, and he is now working with Dalmia Cement Bharat Limited, Ariyalur, as senior manager, lead carbonization, new product development. His research interests include catalyst development, methanol production, working with softwares like Aspen Plus, heterogeneous catalysis, and gas solid systems. I think we are lucky to have a person like Dr. Ullas for this session, where it is very specific. His experience is very specific in the area of carbonization and decarbonization and CO2. So I think with this very short introduction, I welcome once again Dr. Ullas Krishnan to today's session, and thank you very much for accepting our call for this program, and we hope to get a lot of information from your talk. Over to you, Dr. Ullas.
Thank you for those kind words, sir. Am I audible?
Yes, you are audible.
So thank you for organizers of Amarjyoti College, Department of And I'm very happy to be part of this AICTC ATAL Faculty Development Program. It gives me immense pleasure because being a faculty in the initial career stage, like I'm very fortunate to meet again lots of faculties in one platform. And I also thank my organization, Dalmia Siemens, to allow me to go for this presentation. Now I'll share my screen. Let me see. So I need a feedback, like whether my screen is visible.
Yes, sir.
Yes.
And I request all the participants to give some attention to what I am like discussing today. In between, there will be some find the word kind of interaction, where I'll be asking one small question related to one image. So those who are actively participating can answer that. So please respond whenever that slide comes. So today, like my topic for discussion is decarbonization strategies for a climate resilient future. So when you think about climate resilient future, why we think about this is our grandchildren and the great grandchildren should live in this planet. So there is a very great responsibility in each and everyone's life to contribute towards climate resilient future. So what I feel about this presentation is, like, if somebody thinks that carbon dioxide and climate change are going to be whether we are part of that, we should feel 100% that every day, every moment, we are also part of this. So that takeaway should come after this presentation. That's my hope. So generally, decarbonization strategies means we go for renewable energy and then come out with electrical vehicles and lots of windmills. All those things are part of recycling, sustainability. So lots of keywords have come up right now because of the current way in which the global warming is happening, and current way in which this ocean temperature is increasing, or global temperature is increasing. So these things are very alarming. So just a brief about my institution, like Dalmia Siemens. It's having around 15 plants across the state, cement plants spread in 10 states. And it is before the independence. It started 80 years back. And Dalmia Cement started way back in 1930s. And they are very keen in green technology. Lots of e-waste management is there. And this electrical windmills as well as this solar panels for electricity generation is all part of Dalmia's mission. And let me come to my contents for today. First thing, we will have just idea about this. Most of the people have covered, I suppose, because climate change is a major topic. Then decarbonization, carbon footprint, circular economy, and sustainability. All these terms are interrelated. All are known to you. But just have a feel of how we are contributing towards this, because being in a ship of this planet, and we have a hole at the bottom and it is sinking ship, so everybody should contribute to stop the hole, otherwise the whole ship will go down. So whether India comes up or USA comes up or any other country comes up with a solution, it's all good, because we all are in the same sinking ship. And whoever does the problem, like if China is giving more carbon dioxide, or India is giving, or USA is giving, whatever be the case, the whole planet is going to get affected. So keeping those things in mind, like solutions should come from anyone, that is all welcome, because we have to somehow stop this temperature rise of the planet, all these things. Now, just briefly, how this climate change can affect, or the main reasons for climate change, main impacts of climate change, I'm going to brush up. Everybody knows these things. The main thing is global temperature is increasing, and it's getting day by day more. And weather patterns are changing, that we all know now, because what is happening around our climate patterns, everything got changed. and polar ice melting. This been we are hearing for last 20 like 4-5 decades, but sea level rising also we have seen, but the impact of those things are too much to account, because after 100 years things will not be like this. So there are extinction of animals happening. Many things are happening around. Even the shell of crab shell is getting deteriorated. So in future it may extinct, or like that. Many shell are getting affected. Sea life is getting affected. All those things are there, which will altogether will have a major impact. Now, what would be the major solutions? How to end up this climate change is like where we can take part. So ending our like reliance on like fossil fuels, you all know, because it's directly giving a greenhouse gas, that is carbon dioxide, and a greater energy efficient things we have to use, that we have to find out. So there are scope in that direction. Renewable energy, of course, we have windmill, solar panels, but there are ocean technology. All those things are there, but they are all limited, and there are expenditures. And when it comes to economy, there is some issues in that. Sustainable transportation. How many of you will choose to go in cycle rather than bike? So these kind of options every day we have, or pool your vehicle. Like 4 people coming in car to the same destination. If we can all adjust, we can come in the same car. So sustainable transportation is major part where everybody can think upon it. Like you need freedom to move around. That's why you take your own vehicle. But at the same time, taking your granddaughter or grandchild in your mind, there are small things you can do. And sustainable buildings, of course, you all know how buildings are constructed, and what all material we are using. Sometimes we use wood more, and we cut more trees, and all those impacts are there. So forest management comes across with that, and sustainable agriculture. Because agriculture also, we think there is no impact of agriculture. There is a negative impact of agriculture also. And conservation, that is based solution. Conservation based solution is like, I would all suggest everybody to note down one documentary produced by David Attenborough, that is on a life on our planet. So a life on our planet. It is in Netflix available, or you note the name David Attenborough. So that 1 hour video will give you a general idea about the whole climate change that is happening over the last 70-80 years, and how the forest has come down, and carbon dioxide and those ppm levels have gone exponentially rise. Now, the term decarbonization, everybody knows, like we have to reduce the usage of carbon sources, or either we have to convert carbon to some other product. So both things are like either, or we say net zero kind of. Net zero is the word used for what, like we don't want to add more carbon to the system. Either you have to recycle it, or you have to utilize the carbon dioxide which you produce by your own method. So that is a general idea of carbon. And you see, the solution is very simple. That is electrical, renewable energy, and energy efficient equipments. So these 3 things are getting too much focused, and many cutting edge things are coming up. So there is we have hope to save the ship. Those kind of activities are always there. Now comes to a major agreement which you all know, which suppose 2-3 times this word has come in this faculty development program on climate change, that is Paris Agreement goals. So why it is very important is like 2030 is a very key year, because it's only 5 years shorter, and we are supposed to hold the average yearly temperature to 2 degrees and limit global temperature rise to 2 degrees, and limit temperature increase to 1.5 degree. That is a major impact, because that affects the aquatic life, that affects the like microorganisms, that affect the whole ecosystem. So the way the temperature and there is a Panchamrit by Panchamrit on climate change proposed by the government of India by Sri Narendra Modi ji, on to how this 5 accomplishment has to be done, in which 4 of the accomplishment are to be done by 2030. So we are only short of 5 years. And one thing is 2070, which is a 50-year goal. That is quite different. But apart from that, all the 4 other goals, the initiatives have to come from now on. Like it's been proposed a couple of years back, but now it's a high time to react. Now about just Paris Agreement, it is 1.5 degree is the global warming requirement. Like we have to cut short the increase in temperature by 1.5 degree before 2025, and now it has crossed 1.5. So this many countries are coming out of this agreement, because even USA has recently opposed this Paris Agreement part. So, yeah, like the United Nations framework on conversion of on climatic change is major part to be looked upon for the global scenario. Now, when you it comes the question to all of you. Please listen to this slide and get me this particular word. Any of the participants can come up with this particular word. Just a one word actually. It's just a when you combine these 2 words, it becomes a one keyword of current scenario.
Green hydrogen.
Correct, green hydrogen. Yeah, that's nice of you. So it's green hydrogen. So like that, some more words will come in future. So please pay attention to my slides. Now, carbon footprint also, you may be knowing this particular word. How here comes the individual responsibility of a person. Like how much carbon we are emitting, or we are responsible. Like whether the way you travel, the way you dress up, the way you use paper, all those things will count. And we think agriculture is not a big deal, but agriculture is contributing 15% compared to industry, and the electricity also 18%. And we pay more attention to road transportation. It comes only 10% in and around. And like this petroleum and road transportation, we think it's major contribution. And steel industry is giving more carbon. Steel and even cement industry and energy. So this covers the major CO2 contribution industries. So this carbon footprint is there is accounted in 3 ways. One is individual, and one is through companies. Companies' footprint will be major, and then of the product which we buy. Sometimes the product will be of higher cost, but it will be less carbon footprint kind of thing. So there is a choice in each and every day to make whether we should contribute towards our footprint more or less. So this is all like the carbon footprint is very much important when you think about the next generation. Now, this term everybody knows, circular economy and sustainability. But how this I'm not going in deep, but let me tell you overview. It's like one of the ways becomes the input to the other company or other thing to make it into another product. So it's like either reuse, refurbish, remanufacture, recycle, and composting. All those things are there in a circular economy, where one of the ways becomes the input to the other, and it gets recycled and get into these things. And it can tackle climate change and also global challenges, and many other positive things are there in circular economy. So this is a major keyword which almost all the people who are listening here will have some research mind. Most of them would be faculties or research scholars or PG students. Whatever be the case, like this circular economy keyword should be in the back of your mind when you are dealing with upcoming contribution towards a nation building, or whatever be the case. Like you should contribute towards climate or the planet, means the circular economy will be one of the major keyword. Now, eliminate waste and pollution and circulate products and regenerate nature. So this is a circular economy in cut short, driven by this principle. These principles are there to design any product. So whenever you design any product, you can think of these 3 parts, like how to eliminate waste out of it. As chemical engineers, we know the best product, the best reaction would be A and B give only the product, no byproduct. So if a product only forms, we are all happy. If any byproduct forms, then only we need to purify it, because many other unit operations will come up. So eliminate waste. Maximum should not have any waste, and it should not create any pollution. And also the product, after the usage of the product, it should be used for some other higher value. It can be upgraded, or it can be used for some other purpose. And also regenerate nature means if we can like what we have in our mobile batteries and all, so it can regenerate, it can be reused multiple times, all those things. These things, I think it's elementary, but anyway, but you should know, reduce, recycle, reuse, all are the pillars of circular economy. All those things are, and refurbish means how to, just this will give an idea. Reduce means don't buy any gadgets which are of, unnecessarily don't pile up all the gadgets. And reuse means somehow you can use a glass or something and reuse manner. Stitch in time saves 9. This is like repair. And recycling things, which is we should be our nature. Like whenever you get some bottle or something, you try to put it in the waste bin itself. That is also you're contributing towards decarbonization only. And refurbish means like unless you can have one more leg in this, then this is used. It's not a waste anymore. So like that, the mindset should be there to at least refurbish and use it again. Now, listeners, please check with this number, this particular word. Can you come out with this word? Am I audible? Yes. Then, okay. Then can you come up with this word? It's a very simple word. This is about carbon dioxide accounting. I have used this word while I was talking about carbon dioxide. No,
Sir,
if
in
you don't.
chat box it is coming, sir. Net zero.
Okay, I cannot. Okay, net zero. Correct. I cannot see that. That it's fine. Anyway, it's net zero because this keyword should be there in the background when you are into decarbonization. Okay, now we will go to CCUS, which is a major step in decarbonization, where you capture, utilize, carbon capture, utilization, and storage. But in this, we are all lacking on major step, that is transportation. So all major challenge is this transportation, where you have to transport either the carbon dioxide to the utilization area or storing area, or whatever be the thing. The transportation is a costly affair. That is also a major part in CCUS. So basically, in future, people will come up with how to capture carbon dioxide and transport it through tubes or pipelines to a cluster where all the carbon dioxide can be brought together, and then it can be utilized at that plant itself. So these kind of visions are there. Even the government of India is having lots of initiatives towards carbon hubs and clusters, and also utilization hubs will be there, where different technologies will be used. Carbon dioxide will not come up into one product. Different products will be there, and so when we all work on how to utilize carbon dioxide into some product, different products are also possible. And this kind of each and every utilization will have a opportunity to come up with some solutions, like, and also be part of this nation building kind of thing. Now, as I mentioned before, carbon dioxide ppm, like as an year goes, it's keeping on increasing, and you can see the ocean heat, the energy, it's also increasing in the same fashion how carbon dioxide is increasing. So in this way, this trend, and also global average temperature is also increasing in the same fashion. So these there is nothing to hide that carbon dioxide is a reason, and global warming is happening. So some people say climate change is a myth, but these all are not at all correct. When you look into the accounts and when you look into the analysis and data, it's all really showing that carbon dioxide is global warming and climate change is a reality. Now, like I mentioned to you, like India's Panchamrit agenda around climate mitigation. So you see, most of the first 4 milestones, or all the 4 main Panchamrit things are in the year supposed to have accomplished by the year 2030. So non-fossil energy 500 gigawatts, 50% of energy requirement through renewable energy. So people are, when you are working in renewable energy, the business or the area or the opportunity that is going to come in the coming 5 years, you can see clearly here. And also reduce total projected carbon emission by 1 million tons. So this is not a simple value. This 1 million ton is like, it's a very big number they have put there. At least if half is done also, people will be really happy. How to reduce carbon dioxide emissions, and then reduce carbon intensity in the economy by 45% by 2030. When you compare that with the 2005 level. So there's these 4 things has to be accomplished by 2030, and net zero emissions by 2070, because net zero means it's a very tough call. So that by 2070 it has to be accomplished. So this India's Panchamrit agenda is also a torchlight towards the job opportunities for the next generation and the research area where all the faculties has to look upon. The CCUS project, why these things are getting stuck? Many CCUS proposals are there, but you see there are lots of policy makers and regulators are there, and stakeholders are the initial critical first step is like how to who will take up them like stakeholder ownership and go for go ahead without any inhibition and skeptical things about how it will end up. And government has to encourage those who really go for CCUS projects. There should be subsidies, there should be some whatever comes, the government has to really support as a backbone and give some carbon credits and give lots of incentives and initiatives to make them do this. Now, when you go to the CCUS activities, development of CCUS workforce is a major thing where we need lots of chemical engineers and lots of youngsters to work on this CCUS workforce. And what is the workforce need is like they need a R&D development should happen, and then the workforce need is like business mind, like what product you make and what how it can be delivered. All those business mind should be there, or the opportunities to be explored out of CCUS. So these things has to be readily available to the young generation to really take up these kind of activities. And R&D and development, this is happening in almost all the institutions towards the CCUS. But when a model is ready, how to take it forward is like you need people to take equip the skilled people has to be there to take CCUS kind of activities forward. And even without looking too much into the revenue part, they have to work on the social responsibility part, because it's required for the for future of the country. Now, basically, what about the conversion of CO2? This will give an idea which all area you can work upon. Catalytic heterogeneous is the area where I work, and electrochemical catalysis is there, photochemical catalysis is there. Even what happens in a leaf? Have you ever wondered like what happens in a leaf where carbon dioxide and water is put into? With the support of sunlight, with the chlorophyll kind of catalyst, it's able to generate C6 like glucose kind of energy molecule C6 level even in a leaf. So the potential of a photocatalyst, all those things, if you can mimic it, it will become a major breakthrough. But people are even working on it. Artificial leaf, all those things are there. But even then, there is no breakthrough on the economic part. And photo-electrochemical catalysis. This is like when you combine electrochemical also, because this cutting the bandwidth and all those things of the material and making it into form a product. This is even if we say orally, it is very tough to really happen. That energy requirement, the energy barrier, and all those studies has to be done. And when it is heterogeneous catalysis, we will be able to at least say that it's a reaction, A and B react to form. So the reaction time comes, and the catalyst will be favoring the reaction to form the products. But in all other things, the time taken, photochemical, electrochemical, all those things, the time taken and all those things cannot be fixed. And so that's why if a heterogeneous catalysis is coming up, you can model it and make it into bigger projects. But even then, there are combination of hybrid, photo, electro, thermal, biocatalysts, everything is combined to form products like hydrogen, methanol, gasoline, diesel. All those things are possible when you combine CO, CO2, hydrogen. And now, from where this hydrogen comes? So, as a part of decarbonization, you cannot take away hydrogen or green hydrogen or the importance of hydrogen out of the picture. So, how we can source hydrogen is also a major part. That is also a hurdle where people are unable to showcase an economical viable solution. But there are solutions in which power, water, and CO2 comes in to form products. But this water is getting split into hydrogen. And how this water can be split into hydrogen is basically by electrolysis method, and we have to source energy for that. So that energy is a main drawback for any system because it counts to the economy. Now, this even though all these problems are there is a commercial CO2 electrolyzer, which can convert with the water the CO2 and hydrogen to CO, and CO will be then hydrogen from water will react to CO and form Fischer-Tropsch reaction. You must all have heard of it. Now, the products like methanol, ethanol, ethylene, all these can be produced. So these kind of catalysts, kind of electrolyzers, all are coming up. So it's not like these things are not possible. Beforehand, we think like almost irreversible reactions are there, how it can be possible, but there are possibilities. And algae method, microalgae method, which is also another area where you can work upon, keeping in mind how to convert CO2 into some other useful products by microalgae. So this area is also very much even in Delhi, and one major wastewater treatment plant is there in Delhi, where they put the water with the algae and the products are taken out, and they are able to produce hydrocarbon out of this. Now, just about when you get into this strategy of decarbonization, what all things should be kept in mind when you go for any business, any kind of a product line, or how to come up with a self like solution or a startup. So there, this currently you have to know there is no regulatory bodies which are come up with any CCUS activities. So coming 5 years, if this has to come, the government has to come up with lots of policy strategies, find gaps, resource for developing frameworks. They have to come up with lots of drafting of laws and regulations, implement. So there should be like many revolution that happens, like white revolution, green revolution, like those kind of things. In the same way, CCUS revolution has to come. And there are certain activities that is happening, that is kind of preliminary activities on storage pilots. You see, when CO2 is captured as a part of decarbonization, it has to be stored somewhere. When you cannot convert whole CO2 into products, and that kind of technology has not yet come up. So for the time being, like storing it into Assam basins are there, sedimentary basins where exploration has been done, and this rigs like wells which are abandoned wells are there. It can be also used for enhanced oil recovery. The CO2 can be injected as a rather than injecting gas or some steam into the system, we can inject CO2 and go ahead. So how to manage CO2 as a utility and even either store it or use it? These kind of activities have been already done by US, and now India is slowly moving into that direction. India is getting lots of collaboration and data from them. So what has to be done is like you have to explore the since this mining and cement industry, all those people are working. There are lots of wells and even petroleum oil rigs and all those things are there. That is the only area which is away from the public, and we can store CO2 in a much safer manner. So CCS is carbon capture and storage can be managed through storage pilots. So these kind of preliminary works are even started in India, taking guidance from US companies. Basically, it is Baker Hughes and Schlumberger. Now, as I mentioned before, hubs and cluster. There are lots of possibilities of forming a carbon hub, where all the industries, different industries, can source their CO2 and transport that into different hubs. One will be storage hub, one will be transportation hub, one will be capture hub, one will be utilization hub. So when this kind of thing is happening, the investment of each party will be less, and the overall responsibility can be taken by the government itself or some companies itself, and no individual company will get suffered. They only do one of the part. They either capture and give it, they either do the utilization, they either store it, they either transport it. So this kind of carbon valley system, like hubs and clusters, would be the nature. It would be would have to come in reality in future, because then only by 2030 many things can be like as India's Panchamrits on climate change can be established. Now, just to go through the main things, like cluster approach is main important thing. Policy support. You have to take inputs from other countries. How they are doing it, we can. Since we are a developing country, and we have to, we cannot simply pump money on all those things. We have to get where the people can suffer, or where it can bring problem, and from their experience we have to update and go ahead. So countries like Israel, Norway, Singapore highlighted successful policy for support of CCS and related projects. So CCS means carbon capture and storage. So many countries have already proven that CCS is possible. And now how this mapping tools can be done. When you put CCS, means you need to know lots of civil engineering kind of geological activities, where this much pressure and this much CO2 can be injected into the land, and it will not come out into any dangerous situation, or it will not leak out. Also subsurface mapping and all those data has to be generated. So various technologies, including capture method, absorption, all those things has to be done. And this viability of when you go into utilization, how much it is commercially viable, we have to see. Now, regarding the framework of CCUS, even you look, major accomplishment has happened only in European companies, European Union and US. No other, and Australia also have come up with only for CCS, moderate regulatory framework for CCS. So CCUS is, when utilization is now a new word about carbon dioxide, the primary focus was only on capture and storage. But how long and how far we will store CO2? So either we have to stop producing carbon dioxide, or we have to start utilizing it into making it into a fuel, or a solid kind of thing. Solid in the sense back into carbonates. There are methods in which you can convert things into carbonates. So, but the economy part is a major hurdle on those reactions. Now, economics of CCUS projects is a major thing, and bankability and financial de-risking, because you should, when people are skeptical how to de-risk it, like we have to get some assurance on those things, and low carbon products, markets, like there should be a market for, when you come out with some products, that has to be in the market. You cannot produce it in any other method. If we produce it in the CCUS method, it has to be given some privileges. So nowadays we have seen some videos in which this plastic bottles are cut into small pieces and then made into thread, and then a T-shirt is made out of plastic, and a synthetic banian or T-shirt kind of thing, and that is in the market. So whether we should, the choice of wearing it is up to you. But anyway, that synthetic dress and synthetic kind of these things, rather than burning the plastic, rather than just simply diverting it into just melting it and making some product out of it like that. Much better is like utilizing something like making it into a product, low carbon product. Now we can all say like the CCUS would be the main platform for decarbonization, and like there should be a localized solution also, and initial pilot projects, if it is successful, how to make it into large scale. These things has to be national attention should come in each of these kind of activities. And this CBAM is very important, like carbon border adjustment mechanism. This is European Union has come up with this, which is very important related to carbon credits. And also when it comes to any product line, this CBAM is very important when it comes to carbon trade and carbon policies. Now, participation of multilateral platform and international collaboration is a key part for this particular area of global climate change. Now, listeners, please come up with this word, which is right now happening in USA. I hope people are listening to this, so please check with this particular word. Find this word. So this word, anybody is putting in the chat box or something? Since I am unable to see the chat box.
No, sir. Since it is.
Okay. So what this word?
Yeah, one chat is coming, forest fire.
Forest fire, yes. And Los Angeles and all, hectares of land is getting affected because of forest fire. And that is like a uncontrollable reaction. You cannot simply stop it. It's getting exothermic reactions happening. Even the green fields are getting burned like anything, and radiation kind of heating is happening, and it's very dangerous situation. Now, as I said, green hydrogen, I will just just brush up with green hydrogen. How green hydrogen is made. There are different types of hydrogens, like blue hydrogen, gray hydrogen, and all. So when you make hydrogen out of renewable energy sources, this becomes a green hydrogen. There is no role of carbon dioxide coming into the picture, then it is green hydrogen. If you produce hydrogen, it can be used as a transportation method, fuel, and for power generation and many other activities, as a precursor for many production. So hydrogen gas is too much required. So whenever you create hydrogen without the support of any carbon source, this becomes a green hydrogen, and basically from renewable energy. And anything that, even though the hydrogen is produced out of fossil fuels, then it becomes gray hydrogen, which is not at all appreciated. And now, if you make a green hydrogen electricity by burning some fossil fuels, and then then that carbon emission that is coming out of that, and the hydrogen is produced in that fashion, then it is blue hydrogen. Because the electricity produced, basically you use electricity to produce hydrogen. That is something good to produce hydrogen. But that electricity source, if it is renewable, it is green. If it is hydrocarbon or a fossil fuel, then it becomes blue. And if the hydrogen itself is produced by fossil fuel, then it is gray. So people are now totally against gray, and only blue and green hydrogen is under consideration, and basically green hydrogen. So these are things that source. Like the gray hydrogen means methane and coal, and blue also is there where methane and coal is used. And then finally renewable energy is there, means it is green. Now major key players in green hydrogen are Indian government, many institutions are there, ONGC, Department of Atomic Energy, Petroleum, and this kind of GAIL and all those things. And Private players are also there, Adani Group and Tata Chemicals, Mahindra, all these people are there. Now I'll quickly go with the carbon dioxide conversion to different products. So as you know, there are fuels which can be converted. Carbon dioxide can be converted into many fuels. The source of carbon dioxide will be all these things: biomass, fuel, air, and all those things are there. And it cannot non-conversion means it is like carbon dioxide. Like this is used as a utility. Like carbon dioxide can be used in yield boosting of algaes and as a solvent and heat and refrigerant and welding and all those things. Even carbon dioxide can be used as a direct use is possible. It's carbon dioxide is as such. It's not a too much burden, but the quantity required will be very few, like not even 5%. So either it has to be converted into some materials. Now these are the methods, processes available for making into different products, and majorly we can see methanol, methane, and formic acid. All those things are the products, and carbon monoxide. Carbon monoxide is a precursor for Fischer-Tropsch reactions, and carbon monoxide is formed from carbon dioxide is also welcome for many reactions. Now this gives a general idea of what all products can be formed out of carbon dioxide, carbon monoxide, methane, ethane, and so one review paper I have done on this area. So which gives a bulk product and where carbon dioxide complexes in line with petrochemical products. So it can be even a precursor for making many of the petrochemical products. And this carbon dioxide as a no longer a global menace, a future source for chemical is the theme in which I worked upon. So carbon dioxide can be converted into some products. That is the only solution as such available from my point of view. Now, this is actually I put up one case study here, case study on carbon dioxide to make it into products in which area I have worked. That's why I'm just briefing this thing in a fast manner so that anybody who is having a research interest on this can work upon it. So basically, how to activate carbon dioxide into activated carbon dioxide complexes. That is why many studies have happened, right from 1980s to 2020. People are working on this area, where how to activate carbon dioxide into activated complex. And many catalysts have been there in which I have filtered nickel, manganese, and ruthenium and all. And you see, there are requirements for this water molecule dissociation. How water molecules can be made into OH and H+. Like how this water dissociation is possible. So for that also catalyst selection is there, and for the catalyst selection many papers I have referred, and again this manganese, nickel, and ruthenium as standard. And as a catalyst support, many catalyst supports are there for basically for this support material should be have some porosity, surface area, dispersion, all those things are there. So in that manner, the best catalyst support available was TiO2 and preferred on that. Then it comes to generation of a bulk catalyst. Basically, it's about this with a different combination of this manganese, nickel, and ruthenium. I made a different catalyst for the study of CO2 to methanol. Now, these are the basic characterization done. Particle size analysis was done to make the morphology and the other studies. And you can see FSM of this thing, and when you see the structure, it's all a pebble-like structure, and you can see like even in this you can mention, you can see the multi-metal combinations. All the metals are there clustered in this, and when we combine these three metals, it's all well distributed in this catalysis. And then the combination of this is all done in FSM analyzer. FSM analyzer. Now EDAX is also give the combination percentage atomic weight combination of these things, and XRD will give the crystallinity of this catalyst we have produced. And then XPS also give the function, like the valence and functionality of all this. All the chemicals which we have added, what is the what we can say, that the valency or the oxidation state of each and every chemical can be got from this FE-SUM analysis. And when we go for this activity, we have come up with from the literature, we have taken the combination of the catalyst, and a particular concentration is there we have used, which is, I'm not giving the actual combination of this thing because it's a kind of a patented work of NIT Trichy. So I have less freedom to express that. But apart from that, this TiO2 with this combination, we are able to generate a catalyst which can give CO2 to methanol. Now, friends, can you tell me this particular word? If anybody is actually interested listening, you can come up this word very easily. What would be the word from this particular picture? Anybody can check with the first image itself, which also it has a hint over here. Are you able to understand the picture or the word? Anybody? You can check with this picture and get the word.
Sir, one message in the chat box, it is ecology.
Ecology. Okay, echo is correct.
Eco-friendly. Eco-friendly, another message.
Okay, correct. Eco-friendly. Good. Okay. Now, this catalyst we have developed has been checked with micro channel, and the micro channel was developed in the Center of Excellence manufacture of Siemens in NIT Trichy, and we have done the experiment with the CO2 and steam into the system. With the catalyst, we have collected the gas and analyzed in this FTIR as well as GC gas analyzer were used to see the gas this thing, like what all chemicals have been formed, and we could find only less chemicals in the conversion in that. The main reason would be like this maybe the high pressure drop and this surface area. Because of the micro channel, there will be a pressure drop and surface contact will be insufficient, and there are lots of shortcomings in this particular system. So we had to go for also the catalyst morphology. If it is a pebble kind of thing or round kind of thing, it may not be effective. So we had to go for a nano rod kind of another catalyst with the same combination. So synthesis was done on TiO2 nanorods, and we made it in a hydrothermal method. And nanorods were first we visualized it with normal microscope. Even the microscope, we are able to get these needles. And from the needles, like XRD analysis, we could see its TiO2 nanorods have come up very nicely. And all the analysis were done in the catalyst by adding the other chemicals. And you can see the nanorods with 85, 80 nanorods were generated. And when we go for the XRD analysis, we can see the other common manganese, nickel, and all getting distributed in this. And the Williamson plot and all, only those who are technical can get. Now the wide audience may not be able to understand. Now here also you can see this multi-metallic combination in this. So this all the elements were distributed in the nanorods, and we can see many kind of rods here in the catalyst development. And these rods are reason for the operational. Like again, we have done the XPS analysis to give the functionality or the balance of all the catalysts we have used. So this XPS as well as analysis of all those things will give the their actually oxidation state, and TG analysis of after reaction and the spent catalyst were done. We can see there is a increase in spent catalyst. The weight loss is more, so that means it is having something into the system other than the normal catalyst. So this, you see, normal catalyst is 100, and then it's always reducing even if you go for very high temperature. But the percentage, if you see, it is only 1%. Okay, because it is already calcinated up to 700, 800 degrees. So there is no weight loss as such, but the trend of the spent catalyst shows there are some material that is getting lost. That is all because of the absorption of this hydrocarbon or methanol into the system. And better analysis will give the surface area, and this also this analysis is about particle size distribution. This is much lower size, 75 nano and 43 nanometer catalyst we have developed. So overall summary is like the morphology has been done, and the hydrothermal method for TiO2 nanoreels were done, and characterization were performed. Now we went for the design of the reactor, and this porous gel diagram will give the direction to how to really go ahead with the selection of the reactor. So this image will give a fair idea how this we will be sending the gases through this, and because of the flow rate and because of this method, it will get distributed, and total fluidization is possible without the loss of the catalyst. The catalyst will be inside this only, and it will keep on rotating, and as the velocity increases to a critical value. So these are the data for the development of our bed reactor, and this is a general schematic diagram of our setup and this RB flask kind of method. So altogether, this methanol development was done through this, and the CO2 and water molecule reaction finally end up into methanol production, and the kinetics were also studied. Now, can anybody tell this particular word? This particular word we have already covered. What is the first word and what is the second word? I will give you a hint. This is like a circular, and this would be
economy. Circular economy.
Yeah, nice. Okay, circular economy. Now coming to the kinetics, which I am not going to give too much data into that. Now this analysis of the product was done in NMR, and we made sure that this this methanol combination has come up, and XPS like FTR analysis, which is our routine analysis, which is always available in this department. So we went with the STEM normal catalyst and then spent catalyst, product liquid. Everything is showing the possibility of methanol in a very nice fashion. So this analysis is always available in our department, and we can every now and then do this FTIR. But like online FTIR was we were expecting, which is very costly, and we couldn't. So this turnover frequency and these things are done to find the effectiveness of individual catalysts and overall catalysts and the percentage of methanol formation. Now the mechanism, which will be of very interesting for people, because how when you say like CO2 plus water molecule giving methanol, what is the inter reactions? CO2 can be activated to form CO and O star, and H2O can be activated to form OH and H plus, and CO and OH will form other intermediates, and these intermediates will combine finally to form methanol. So it's recombine and combining of these things, and it's the positive thing is always that it will come up with oxygen, and we have a direct oxygen dissolved oxygen meter, which is also showing oxygen generation in the system. So the reaction was only with CO2 and steam, but we are able to generate oxygen out of it, which indirectly shows the methanol is also formed. And the kinetics were also studied, but it is all low concentration, up to 9 or 8% is there, and we cannot say like too much onto all these kinetics to that extent. We cannot say it's strictly second order; it's a pseudo second order kind of thing. Now, this word, anybody can respond to this particular word? You have to think like this is like a subject name. What is the left subject name? You must have all studied up to 10th, and if you are into engineering, genetics, okay, fine, but basically, don't go deep. You must have dropped that subject to go for engineering.
Biology.
Okay, then short form of that. That is all correct only, but you have to take only half of it, and then this is showing different kind of people together.
Biometric.
No, bio is correct. Correct, biodiversity. Nice. Correct answer. Okay. Now we went for the optimization with the there are like design expert software to optimize it. Then only we can go for a solution to which all values we can fix and go ahead. There are resistance time, molar ratio, and catalyst ratio, because molar ratio is very important. There's a water ratio and CO2 ratio is not like stoichiometrically you can go ahead. Sometimes the water molecule ratio should be low, and the catalyst loading should be more, temperature should be maintained. So all those things were analyzed, and we have gone for a design expert with some 30 runs, and we are done and came up with a surface floats methodology kind of thing, and we have come out with the data. That data has been used to transfer to Aspen Plus simulation to go into a model of 200 kilogram per mole, and we did in Aspen Plus this particular reaction, and even though it's we have taken this Gibbs method, which is stoichiometrically may be feasible, but the activity of individual catalysts we cannot sell. But we have limited the percentage and conversion rate and all those things, and we have generally come up with some solution like it can CO2 and water molecule can go to a catalytic reactor, and then it can be go to a distillation unit where 100% the methanol can be taken. Unreacted carbon dioxide can go with the oxygen, and oxygen can be either absorbed to a mine solution or some other method, and then the dissolved this desorption unit is there to give the reaction of CO2 or unreacted CO2 back into the system. And here in the distillation unit, the unreacted water molecules will get condensed. That can be also given back as a reactant. So this scheme is of industrial application, and this theme would be of relevant for many activities. And then this parameter influence have been studied with this particular software, design expert software, and the optimized value was used in Aspen software. And the yield is found to be enough to be considered this process as a choice for handling issues related to global climate and energy. Because when you are able to generate methanol out of CO2 and water molecules, we have to pay attention to this and go ahead with that. And reaction thermodynamically feasibility was also studied, and 9% only reaction is there, but we can build upon it. We can add more catalyst or more other ingredients and study on this. So overall, I can say that TiO2 nanoroad supported trimetal catalyst has been synthesized. Patented catalyst has been synthesized, and then heterogeneous conversion of CO2 to steam for methanol is done. And then this metal oxides independently how they are working was also analyzed using TOF for turnover frequency studies. And this study assures towards a discrete route of CO2 sequestration using multi-metal catalysis for in situ hydrogen provision. That is very important, like in situ hydrogen, hydrogen as well as OH species, hydroxyl surface groups are there. Because of the catalyst, hydroxyl surface groups are formed, and hydrogen is also formed, and water molecules and in the catalyst active sites ensuring methanol production. Now, major accomplishment of the work was like selection of catalysts, which I have already discussed, and protocol to synthesize. That is a major thing. That is a part of patent of NIT. And then fluidized porous design, which was very critical because the catalyst should not be leaked or should not go out, and it should condense in the system. And sensitivity analysis was done using the design expert software, and methanol production from this was documented, and a pilot plant scale model is suggested using Aspen Plus software for commercial applications. Now again, coming back to our own topic, that is the climate change what are the major solutions? Apart from all this research and activities, we have to think upon like how to end the usage of reliance on fossil fuels, and greater energy efficient system has to come. Renewable energy methods. There are even methods, renewable energy has come up into different methods like wind energy. Even the when train is going, it is going in high speed. It can rotate something. It can generate energy by itself. Even in bike, people are trying to find renewable energy sources. So if you find something that is rotatable, it can convert this mechanical energy into electrical energy. So you should not limit yourself as a chemical engineer. We have to think about like an environmental engineer, and we have to explore different methods in which this energy can be converted. We cannot, we can only do like conversion of energy from one source to another. Nothing else we can do. So how to tap solar energy and convert it into different energy is what the whole world is doing. So we can also do that, but in in engineering perspective, how to do that we can check. And also sustainable transportation. Again and again, I'm thinking about when you are, if you can have an online method, online this conference. This is much better than if I travel and come in person. But the in-person relationships are different. The FDP program will be different when you are in person. But at the same time, you are getting a platform. How many of you are actively listening and utilizing this platform is another takeaway. But at the same time, I feel like limiting and clustered kind of transportation. And I'm wondering, like even China is having a cluster kind of building where within the building itself they have all the offices, all the schools. It's like a different flat of different activities. One is hospital flat, one is educational flat, one is office flat, one is living flat, and all these flat apartment clusters are within one hub. So even 10,000 people are living there. So their transportation is limited, their activities are their cost of living is very less, and this kind of cluster kind of living is quite possible for a sustainable building and sustainable cost of, like way of life. And forest management, again tell you people to if at all you get time, David Attenborough's a life on our planet. So that was his 20 years of experience, and I mean 70 years of experience. Yes. He's right now around 100 years of age, and he has given this lecture at the age of 90. And that one documentary has changed my life. That's why I'm again. It's about the how nature is itself able to solve things if we keep quiet. If we give some time, nature will heal. But we have to limit. We have to somehow give time to the nature. That is about the Chernobyl. This nuclear outbreak happened in Russia, in Ukraine actually long back. The Chernobyl area has become abandoned, and then after 30 years it became green. So he was coming up with the solution, like nature will come up with its own solutions, but it should not take away our freedom of life. The nature will sometimes become very adamant in changing things, and in between we will all human beings can get suffered. So we should not take chance on nature to take such a gracious action against us. So we have to conserve the nature. We have to always keep in mind like Mother Nature has to be really supported in our manner. Now, how many of you can? We are coming into the end of the presentation, so please pay attention and give this particular word. Any takeaway? Anybody who can attempt this? Any idea? This word is very, to be frank, in decarbonization or climate change and global situation.
Yeah, one message in chat box: carbon card, carbon credit, carbon footprint.
Carbon card will end to carbon credit. Yeah. Actually, it is rather than footprint, it is card only. So carbon credit card. Okay, so in that you can take the credit part. And this is very simple. I think most of you are will be able to get the right end, but left you have to say climate change. Yeah, correct. Climate change. So let me come back to my working institute, Dalmia Cements, Dalmia Bharat Limited. So they have like around 15 planets in 10 different states, and it's like I am stationed at Ariyallur, which is in north part of Tamil Nadu, and the overall our plant is very much having you see solar panel kind of electric generation, which is around 50 to 60% of our electrical requirements. And globally, many initiatives are towards this decarbonization theme. So that's why in future also there will be lots of opening in decarbonization area in across all the industries. So I am very happy to be part of this ATAL AICTE ATAL FDP program, and I am very happy that you all were listening to my this particular session. And I request anybody, if you have any question, anything related to decarbonization and about the work I have shown, you can feel very free to ask. Don't get into inhibition like what will happen if you ask something. Please be ready to ask some questions. Thank you. Any questions from the audience? I think the pace in which I have gone maybe a little fast, and lots of things must have got accumulated. But anyway, I have come to the closure of my talk. Any questions is there? I'm unable to hear actually. Yes, ma'am. I couldn't hear you. If you cannot talk properly, you can even put in the chat box, and organizers can read it. Yeah, please.
So actually, Dr. Srilashmi has requested in the chat box whether would you be able to repeat the name of the documentary?
Yeah, it's David Attenborough. David Attenborough, A Life on Our Planet. David Attenborough, his documentary is in Netflix, A Life on Our Planet. I didn't get you. Just a second. Is my screen shared now?
No, sir, it is not shared.
Okay.
Now it
What
is
about
visible.
now?
Now it is
Okay.
visible.
So this is the thing. Like David Attenborough, A Life on Our Planet. A Life on Our Planet. Am I clear with that? Let me see the chat. Okay. Any more questions is there?
Sir, I had a question.
Yeah, please go ahead.
So you introduced a concept called clustered buildings.
I didn't get you again, please.
And in this concept, do you think the social and cultural aspects of a country like India will be hindering the practicability of it?
You see, it starts from each and every person. Like, how many of you carry, metal water bottle, and how many of you can take those, individual steps? How to use a reusable pen? How to it should be inculcated in each and every person. Like that should be from the school days onwards that has to be taught. And I feel like there is no hurdle. Like when you think of 10 years back, people using mobile was very tough. Everybody will use. Everybody will go for UTI, online transactions. Those things were very tough to conceive 10 years back. But now everybody is using, and even now we cannot find a person who is not using this kind of thing. So if the nation wants this, if the whole planet has no other go, then it becomes a mandatory thing. Now you see, previously hard copies were required for everything. Now even online is fine. So like that, the paper cut short has happened in many areas. So slowly people will come to know that we cannot, unlike before, we cannot use plastics. Unlike before, we cannot travel as and when you want. All those things, that education will come. That's what I feel. Cultural, all those things are there, but you see, everywhere changes are happening. We have limited, in Corona time, many of the things were limited. And that was a learning. Like even we can stay back and get things done. That was a message actually. And there will be other problems can come, but be positive to, ultimately, what about your grandchildren? Whether they have to be in a world where you should be always with a mask, you should be always with a oxygen generator and, cooler in your body itself. That kind of situation is, it's not too far. So we have to avoid those things. That's why what I feel is everybody should take it into their heart. Like decarbonization is not a small thing. It should be in everyday life.
Thank you, sir. Are there any more questions from the participant side? So seems like there are no questions.
Yeah, we can. Okay.
I kindly welcome Dr. Suratsi Rajan for the vote of thanks.
So it is with great pleasure that I extend a heartfelt thanks to our esteemed speaker, Dr. Vilas Krishnan Jain. The depth of your knowledge and the clarity with which you conveyed complex ideas have left a lasting impression on all of us. Your passion for the subject was evident, and it has inspired us to explore new avenues and adopt innovative approaches in our own fields. We are deeply grateful for the time and effort you invested in preparing for this session, and your willingness to share your expertise and experiences with us is truly appreciated. Your contribution have significantly enriched our understanding and have provided us with valuable takeaways that we can apply in our professional lives. I would also like to express our appreciation for your engaging and interactive approach. The discussion were particularly valuable, allowing us to delve deeper into the subject matter and gain a more comprehensive understanding. In conclusion, thank you once again for your exceptional presentation and for being a part of our faculty development program. Your insights have made a profound impact, and we look forward to the possibility of collaborating with you in the future. As a token of gratitude, Department of Chemical Engineering, Amal Jyoti College of Engineering, sharing a virtual memento with you, sir.
Thank you, Suresh sir.
Thank you so much. Yeah, thank you, sir.
Thank you very much, sir. Thank you for. Thank you for joining with us today. Now we'll move on to the next session. Our next session will be on the topic hydrological responses to climate change. And to introduce and welcome our next speaker, I kindly invite Dr. Surat sir.